Welcome everyone to the next part of the tutorial video sequence from Pros and Experts. Please do like and share our videos. Also subscribe for getting our new parts of videos. Okay, now let's jump into the next question. Check the causality and stability of the system whose impulse responses are given. There are two questions. Question A. You are given an impulse response h of t equal to e raised to at u of t, and a is less than 0, is negative. Okay, a is negative. Right. So first let us check the causality. First of all, for causality, a system is said to be causal if no values of its h of t lies in the negative time axis, or we can say h of t has 0 amplitude for t less than 0. That is in the negative time axis. Okay. So first of all, let us try to plot h of t. That could be very easy for you to judge whether this is causal or non-causal. Okay, so let us try to plot causality. Try to plot h of t. Okay, listen how to plot h of t equal to e raised to at u of t. What kind of a signal is e raised to at into u of t? Actually, what is e raised to at? What kind of a signal is e raised to at? You may jump onto the conclusion that e raised to at is an exponentially increasing signal. But no, listen to the question very carefully. It is said a is negative. So you are dealing with an exponential signal for a negative, like e raised to minus 3t u of t or something, right? Here a is negative. Okay, so e raised to minus 3t is an exponentially decaying signal, and the signal is of infinite duration, from negative infinity to positive infinity. Okay, and now this e raised to at for a negative is multiplied with u of t. What happens? All the values in the negative time axis, in this axis, will be multiplied with 0, because u of t is 0 in negative time axis. So the signal truncates like this. Okay, so this is h of t equal to e raised to at into u of t for a negative. Okay, now on a single glance you can judge whether this system represented by the impulse response h of t equal to e raised to at u of t is causal or non-causal. What is it? It is causal. Definitely it is causal, because on the negative time axis we cannot see any amplitude for h of t. H of t is completely 0 in this axis, so the system is causal. Okay, that accounts for the causality of the system. Next, we have to judge the stability of the system. Okay, again, let me say, stability can be easily judged by just looking at the impulse response. So just looking at this impulse response, how can you judge or comment about the stability of the system? For a system, for an LT system to be stable, what is the condition? The condition is the impulse response must be absolutely integrable. The impulse response should be absolutely integrable. What does that mean? That means integral minus infinity to infinity modulus of h of t dt should be a finite value, something less than infinity. That means, that is the meaning of saying absolutely integrable. Okay, so I have told you, just by looking at this impulse response we can judge whether the system is stable or not. So this signal has a decreasing amplitude, right? Exponentially decaying amplitude. Okay, so that means at some time t this amplitude approximates 0. So integrating this signal from minus infinity to plus infinity will give you a finite number, right? Because the area is converging, this signal is converging, the area is going to be finite. So we can say that simply by looking at h of t, we can say that this system is stable. Or if you want a mathematical proof, let us do that. So this is the condition, integral or minus infinity to infinity h of t dt should be less than infinity. Let us try to solve this integral. Integral minus infinity to infinity. Again, you don't have to integrate it from minus infinity to plus infinity, because the signal is only existing from 0 to infinity. So integral 0 to infinity. Modulus is not applicable here, not wanted, because it is a real signal. So instead of h of t, I can write e raised to at into dt. U of t is not needed because the signal has already truncated from 0 to negative time axis. Okay, so we have to find the value of this integral 0 to infinity e raised to at dt, provided you have to take care that a is negative. Okay, a is negative. Now what is this integral? This is e raised to at by a from 0 to infinity. Okay, why can't we apply the limit? On applying the limits, it becomes e raised to, what is e raised to a into infinity? E raised to a into infinity, normally you would think e raised to a infinity will tend to infinity, but I have told you our a is negative, so you are multiplying a minus something, minus quantity with infinity. That means this value tends to what? 1 by e raised to infinity. Okay, e raised to minus a infinity is actually tending to 1 by e raised to infinity, or equal to 1 by e raised to infinity. That tends to 1 by infinity, and 1 by infinity, it goes to 0. Okay, so I can write here e raised to a into minus infinity is 1 by infinity or 0. Okay, that is what you get when you put the upper limit. Now what is the lower limit? It is 0. So e raised to a0 is 1. Okay, so the answer is going to be 1 by a. We are not interested in what the answer is, but we are interested in whether it is a finite value or not. So this is a finite value. Okay, so we can say that integral minus infinity to infinity h of dt is a finite value. Therefore the system is stable. Okay, that's the answer to the question 1. Let us check on to the question B, where you are given a discrete impulse response given by 2 raised to n u of minus n. Okay, first we check on to the causality of the system represented by this impulse response. So causality can be judged by looking at the impulse response graphically. Okay, so we know that 2 raised to n is a signal, right? 2 raised to n is an exponentially increasing signal, right, in both sides. Okay, this is 2 raised to n. Now in the impulse response, 2 raised to n is multiplied by u of minus n. What is u of minus n? U of minus n is u of n in its time reversed fashion. Okay, time reversed fashion with amplitude 1. Okay, now these two signals are being multiplied. The signal is multiplied by this signal, and what you obtain is, you will obtain 2 raised to n as such, because 2 raised to n is multiplied by 1, but the samples will be existing only in the negative n axis. But the samples will be obtaining only in the negative n axis. Okay, so I can tell you that this signal is same as the signal, right? Same as the signal, because you are multiplying this signal with 1 all over the negative n axis. Okay, so our question is to find out the causality of the system. What is the causality? The system is simply non-causal. Okay, non-causal or anti-causal. Okay, because h of n is not equal to 0, because h of n is not equal to 0 for n less than 0. Okay, so this is the answer. System is non-causal. All right, next we will check on the stability. Again, I'm inviting you to just look upon h of n and tell me what is the state of stability of the system. Is it stable or not? it is stable because you know the signal is converging, right? The envelopes are decaying as we go to the negative infinity. Okay, negative n-axis, right? The signal is decaying or it is converging, right? Or else we can check it mathematically also. So to be stable, for stability, sigma n equal to minus infinity to plus infinity mod h of n should be finite. That is, we call it absolutely summable, right? So if only the impulse response is absolutely summable, we can say that that system is stable, right? So let us check on. That implies sigma n. What is the limits of the summation? Is it from minus infinity to plus infinity? No, because the signal extends to only to negative n-axis. Okay, so I can write sigma n equal to 0 to minus infinity, right? Starting from this sample, 0, minus 1, minus 2, etc. up to infinity. So n equal to 0 to minus infinity. What is mod n? Mod h of n? It is 2 raised to n. You don't have to write u of minus n any further because we have truncated the signal to the left of n-axis due to the presence of u of minus n, and u of minus n is 1 in that interval, so you don't have to write it any further. So this is sigma n equal to 0 to minus infinity 2 raised to n. The only choice before us is to expand that summation. So putting n equal to 0, you will get 1. 2 raised to 0 is 1, plus what is the next n value? It should be minus 1, not 1. It should be minus 1 because 0, the next sample is at n equal to minus 1, then minus 2, and goes on. Okay, so at n equal to minus 1, you will get 1 by 2. Then n equal to 2, you will get 1 by 2 square, and it goes to infinity. Okay, that is this sequence is obviously a GP, geometric progression, infinite geometric progression, with the first term is 1 and common ratio is 1 by 2. And since common ratio is less than 1, we can directly use the expression sum is equal to a by 1 minus r. Okay, we can use this expression. So the sum is a is 1 divided by 1 minus 1 by 2. All right, a by 1 minus r, that is equal to 2, right? So we are again not interested in what the value is, but is it whether finite or infinite. 2 is, of course, it is a finite value. Therefore, what we have obtained is sigma over n equal to minus infinity infinity h of n is a finite value. Therefore, system is stable. Okay, that concludes the answer. So the next question is, find the output of an LTI system whose impulse response is h of t to the input x of t. Given h of t equal to u of t minus u of t minus 1, and input x of t is given as in the figure. Okay, listen here, the figure, I mean x of t is a two-sided pulse, right? It is a two-sided pulse. Till now we had done questions where x of t and h of t were just pulses, only a single side pulses, but here it is bipolar. It has positive 2 amplitude and minus 2 amplitude. But if we know the procedure, if we know the concept, we will move on as per the same procedure and we will get the output. Okay, there's nothing to worry about if you're given this signal as bipolar. Okay, so our procedure, as you know, it is first to find out x of tau by simply changing t to tau index, then find out h of tau. Okay, then finding h of minus tau from h of tau, and finally taking h of t minus tau, which is t units shifted version of h of minus tau. Why are we doing this? Because our aim is to realize this equation, y of t is equal to, or y of t is equal to convolution integral is given by minus infinity to infinity x of tau into h of t minus tau d tau. Okay, so in order to realize this equation, we need to get x of tau, then h of t minus tau. That's why I'm taking x of tau and h of t minus tau. Okay, So as a first step, I have drawn h of tau, x of tau for you. That is the input. Okay, x of tau is in the index tau. Next, I have to draw h of tau. But in the question, it is given h of t equal to u of t minus u of t minus 1. Okay, so I'm directly drawing h of tau. Okay, this could be our h of tau, right? H of tau, because it is u of t minus u of t minus 1. So it is a pulse from 0 to 1 with amplitude 1. Okay, u of t has amplitude 1. Okay. Now our next aim is to find out h of minus tau. Then only we will get h of t minus tau accurately. Okay. So next I will draw h of minus tau. Okay. So this is h of minus tau. By time reversing h of tau, so this 1 comes to minus 1. This is minus 1. And the amplitude is unchanged because it is only a time operation. Amplitude will never change. Okay, so this is h of minus tau. And now what is h of t minus tau? H of t minus tau is h of minus tau shifted by t units to the left initially, assuming t is negative. Okay, so h of t minus tau is to be realized from h of minus tau. H of t minus tau is obtained by shifting this value, so shifting this signal, and initially this t is assumed to be negative. Okay, so this signal will be shifted to negative t axis. So this is h of t minus tau, where h of minus tau is shifted by t units. So this n becomes t, and this is t minus 1 because the duration is 1. Okay, and the amplitude is still 1. Okay. Now what you will do is you will realize this equation. Okay, integral minus infinity to infinity x of tau into h of t minus tau. So in this condition, when t is very negative, that means this signal is shifted to the negative axis. What is the product of x of tau and h of t minus tau? It should be 0. Okay, because this signal is multiplied by 0 in this axis. Okay, so initially you can say y of t is going to be 0. Okay, now as per our original procedure, we are what we are doing is we are incrementing t, right? We are incrementing t. That means we are shifting the signal to the right side gradually. Then we are again comparing the product x of tau into h of t minus tau. Still they are 0, and we judge that this product becomes 0 or remains 0 until this t is less than or equal to 0. Okay, until this signal is coming close to x of tau in this axis, their product remains 0. Okay, so I can write y of t equal to 0 until the t means the trailing edge. This trailing edge is less than or equal to 0. Okay, so there goes our first condition of the output, y of t equal to 0 for t less than or equal to 0. Okay, I can write it somewhere for final consolidation. Okay, I will take up this. I will take up a space for consolidating. So y of t equal to 0 for t less than 0. Okay. Now what is the next procedure? We are incrementing t until t less than 0. Okay, so we got output 0. Now we are again incrementing t. So this signal enters under or overlaps with x of tau. Okay, so I'm saying that while slightly incrementing t, the trailing edge or leading edge of this signal, overlaps with x of tau. Okay, but the trailing edge is still outside x of tau. Okay, I can draw this. Okay, so this is such condition. The leading edge is overlapping with our x of tau, right? X of tau, but the trailing edge is out of x of tau. Trailing edge is t minus 1. Okay, and the amplitude is still unchanged 1. Now, before calculating the product of the x of tau and h of t minus tau signals, let us first check what is the time interval in which this product is valid. So time interval is calculated by, t is greater than 0, so that this edge is overlapped, right? So t is greater than 0, and what is the next condition? The trailing edges not overlapping. Okay, that means t minus 1 is less than 0. So and t minus 1 less than 0, that will give you t greater than 0 and t less than 1, or combining 0 less than t less than or equal to 1. So this is the new condition in which we are going to evaluate the output. Okay, so what is the output there? Y of t equal to integral. What should be the limit of integration? Carefully note that the two signals give non-zero product only within the interval 0 to t, right? 0 to t. Beyond 0, this signal is 0, and after t, this signal is 0. Okay, so these two signals are overlapping in this in this interval 0 to t, right? 0 to t. So integral 0 to t from the equation x of tau into h of t minus tau. Okay, what is x of tau? In this interval 0 to t, x of tau is 2 units amplitude. Okay, 2 into, and in the same interval, what is x of t minus tau? That is 1 unit. So 2 into 1 d tau, that is 2 into t. While applying the limit, you will get 2 into t. Okay, so the output y of t equal to 2 into t. Within the interval, we have already derived the interval 0 less than t less than or equal to 1. Okay, so I can consolidate it. Y of t equal to 2t for 0 less than t less than or equal to 1. Okay, what could be the next step? We are again incrementing t so that the signal is moving further right side. Now what is the next conspicuous change in the product? What or when will that product change? I can say when this leading edge crosses the negative pulse, right? Here it is a negative pulse. So this leading edge comes and crosses the negative pulse, but the trailing edge is not crossing the negative edge. Trailing edge is okay inside x of tau, but it will not cross the negative pulse. I can draw this condition as, so I can say the next condition occurs like this. Okay, the leading edge is inside the negative axis, negative pulse in the x of tau, but the trailing edge is out or behind the negative pulse. Okay, behind the negative pulse. So this is t minus 1. Okay, now the first, before calculating the product, the first step behind us is calculate the time interval in which this output is valid. Okay, what is the time interval? You can perfectly see that time interval can be judged by the time values when the product of these two signals remains non-zero. So while we integrate from t minus 1 to t, the product is going to be non-zero. At all other times this signal is 0, so the product will be 0. Okay, again here there's a catch, because we have, for the first time, we are dealing with a signal which has a negative pulse, right? Negative pulse here. There's a small catch, a simple catch, but what you need to know is x of tau is having an amplitude change at t equal to 1. Okay, at t equal to 1. This is t equal to 1. Okay, so y of t is equal to integral t minus 1 to 1. Okay, in t minus 1 to 1, what is x of tau and h of t minus tau? In t minus 1 to 1, x of tau is 2. Okay, x of tau is 2 and h of t minus tau is 1. Okay, so 2 into 1 d tau. Okay, the integral is not over, plus we have to separately integrate from 1 to t also. So integral 1 to t. Okay, integral 1 to t. What is x of tau into h of t minus tau in integral 1 to t? You can know. Now here listen carefully. In integral 1 to t, or in the interval 1 to t, x of tau is minus 2 and not 2. Okay, x of tau is minus 2 and h of t minus tau is 1. Okay, so we can write minus 2 into 1 t tau. That is equal to 2 into tau from t minus 1 to 1 minus, here it is a minus 2 into tau from 1 to t. Now applying the limits, 2 into 1 minus t plus 1 minus 2 into t minus 1. That will give you 2 into 2 minus t minus 2t plus 2. That is equal to 6 minus 40. Okay, 6 minus 40. And now what is the time interval in which this 6 minus 40 is valid? Actually we had to found it out earlier, but okay, no problem, we can find it right now. Anyway, to obtain the time interval, we can see that this t is greater than 1, okay, but less than 2. All right, I can write it as t is greater than 1 and t is less than 2. Okay, and what about t minus 1? T minus 1 is less than 1. Okay, t minus 1 is now less than 1. Combining this, we can write t greater than 1, t less than 2, and t less than 2. Okay, these two are redundant. One, you have to consider only one. So t greater than 1 and t less than 2. That means this is valid in 1 less than t less than or equal to 2. Okay, so that is the next condition of output. Y of t equal to 6 minus 4t for the interval 1 less than t less than or equal to 2. So I can consolidate it. 6 minus 4t for 1 less than or equal to t less than or equal to 2. Okay, fine. Alright, what is the next condition for deriving the output? It is, again we are incrementing t, that means shifting the signal to the right. So what happens is, this leading edge now, which is now under x of tau, goes out of x of tau. Okay, it's no more overlapping with x of tau. And what happens to the trailing edge? This trailing edge comes to the comes under the negative pulse of x of tau, but not out of x of tau. Okay, so the leading edge is out of x of tau, but the trailing edge is inside x of tau. I can draw it. So listen, this is such a condition. Okay, the leading edge is out of x of tau, but the trailing edge is still inside x of tau. Okay, now how can you express this condition? It is very clear that t, the leading edge is greater than 2 and the trailing edge is less than 2. T minus 1, trailing edge is less than 2. Okay, which means t greater than 2 and t less than 3, or that means it is 2 less than or equal to, 2 less than t less than or equal to 3. Okay, now we are going to derive the output in this condition, this interval. Therefore y of t is equal to, what we need to look up at first is the limit of this integration. You can see the limit where these two signal product of these two signals remain non-zero is only from t minus 1 to 2. Okay, from t minus 1 these two signals are non-zero, up to 2 these two signals are non-zero. Okay, after 2 this is 0, before t minus 1 this one is 0. So the limit of integration is from t minus 1 to 2, t minus 1 to 2. Then x of tau is listen, x of tau in this interval t minus 1 to 2 is it 2 or minus 2? It is minus 2, not 2. Okay, so minus 2 into 1, because h of t minus 2 is always 1, d tau. Okay, and what you will end up with is minus 2 into tau within t minus 1 to 2, which is equal to minus 2 into 2 minus t plus 1, which is equal to minus 4 plus 2t minus 2. Okay, so this implies y of t is equal to 2t minus 6. Okay, 2t minus 6 in the interval. Which was interval? We have derived as 2 less than or equal to 2 less than t less than or equal to 3. Okay, so I can consolidate it as 2t minus 6 within 2 less than t less than or equal to 3. Okay. Now, what is the next condition? Again, we are keeping on incrementing t. So this leading edge goes further into the positive t axis. And now what happens is the trailing edge also moves to the right, so that at a particular time it also gets out from x of tau. Okay, it is no more overlapped with x of tau. So I can draw that condition. This is somewhat like that condition. All right, so the leading edge is t, trailing edge is t minus 1. Now t minus 1 is also out from x of tau. How can you express that? T minus 1 is now out of x of tau, means t minus 1 is greater than 2, right? T minus 1 is now here. Okay, it is greater than 2. Okay, that means t is greater than 3. Okay, t is greater than 3. And in this new interval, what is y of t? You don't have to evaluate y of t, because perfectly it is 0, right? Because this signal is multiplied by 0 here. Okay, that will give you 0. So x of t will be continuing to be 0 for t greater than 3. This is the final expression for, or final part of the output. So I can keep on consolidating it. Y of t equal to 0 for t greater than 3. Okay, so this is our final output. Okay. Okay, so what's the next question? For the given signal, plot x of 3 minus 3t. Okay. So the question is to plot x of 3 minus 3t, but you know x of 3 minus 3t is same as, I can write it as x of minus 3t plus 3. Okay, so again we have a shifting operation as well as a scaling operation occurring in this signal processing. So what we do is we adopt precedence rule. Okay, as per precedence rule, we have to first shift the signal from the original signal x of t. Okay, so x of t to x of t plus 3. Then from x of t plus 3, you need to find out x of minus 3t plus 3. Okay, that's what precedence rule says. Okay, I have redrawn x of t for you. Now, according to precedence rule, what we have to obtain is x of t plus 3. But you know, x of t plus 3 is a time shifted version of x of t, but shifted to left by 3 units. Okay, so if you are shifting x of t to 3 units to the left to obtain x of t plus 3, then what will happen at this point? This point comes to 3 units to the left. That means it is at minus 9. Okay, similarly this portion, this amplitude will be shifted to minus 6, right? Minus 6. Then 0 will be shifted to minus 3. T equal to 3 will be shifted to 0, and t equal to 6 will be shifted to 3 units to the left, that is 3. Okay, so the signal will start at minus 9 and will end at 6. That is how you shift the signal by 3 units to the left. Okay, so let me draw this. So this portion without any change in amplitude. Okay, now this portion is at 0. Okay, because you know, this 3 will be shifted to 3 units to the left, means you will end up at 0. Okay, then finally 6, the end of the signal will be shifted to 3 units to left, means it is at 3. Okay, again amplitude is 1, not changed. So this is x of t plus 3. Now so we have reached here. Now what is the next step? We need to find out x of minus 3t plus 3, which is the final answer. Okay, let's see how x of minus 3t plus 3 would look like. So what we have to do is, from x of t plus 3, you scale by minus 3 units. Okay, you scale every time unit by minus 3 units, and let us see what happens. So at minus 9 divided by minus 3. What is minus 9 divided by minus 3? It is plus 3. Okay, so this amplitude, this portion as such goes to plus 3. Okay, right. Similarly, minus 6 divided by minus 3 will give you, minus 6 by minus 3 will give you plus 2. So So this portion will go to plus 2 here. Okay. Similarly, what happens to 0? 0 divided by minus 3 is still 0. So this amplitude will remain at 0 itself. And finally, what happens to 3? This 3 will be divided by minus 3, and that goes to minus 1. Okay, 3 by minus 3 is minus 1, so that portion goes to here. So a flipping occurs, automatically a flipping occurs. So I can draw it as minus 9 will go to plus 3. Okay, and minus 6 go to 2. So this portion will come something like this. Okay, here it is 2. Right, now what happens to this portion? What happens to 0? 0 remains at 0 itself. Okay, so I can connect like this. 0 remains at 0 itself, right? And now what happens to this unit here? 3 divided by minus 3 will give you minus 1. Okay, so this portion goes to minus 1 like this. Okay, and the amplitude is not changed. So this is the final answer you need to have, that is x of minus 3 plus 3. Okay, the next question is, classify the following signals into energy, power, or neither. Determine energy and power. Okay, the first question is e raised to 2t u of minus t. So e raised to 2t u of minus t will be, we have come across the signal many times. So e raised to 2t is actually an increasing exponential signal like this. But when you multiply with the u of minus t, what remains is left side of the t-axis, negative t-axis only. Okay, so this is e raised to 2t u of minus t. Okay, and this signal is actually a decreasing exponent, right? In the negative t-axis, it is a decreasing exponent. So its area is converging. The signal is converging. Such signals are always energy signal. Okay, such signals are always energy signals. But let us see mathematically whether it is energy signal or power signal. Okay, so since we had an intuition about the signal that it can be an energy signal, let us just find energy first. So energy, the expression to find out energy of a signal is E equal to minus infinity to plus infinity mod x of t the square dt. Here modulus is meaningless because it is a real signal. So this becomes integral. What is the limit of the integral? The limit of the integral should be from 0 to minus infinity, right? 0 to minus infinity, because the signal extends only from 0 to minus infinity. Okay, so 0 to minus infinity, x of t square. What is x of t square? It is e raised to 4t. Okay, now there is no need to write u of minus t, because the effect of u of minus t is already there in the signal by truncating its positive t part. Okay, so e raised to 4t dt. What is this integral? It is e raised to 4t divided by 4 from 0 to minus infinity. Okay, now let us apply the limits. That will give you 1 by 4 into e raised to minus infinity, right? If you substitute minus infinity for t, it becomes e raised to minus infinity. And what is e raised to minus infinity? E raised to minus infinity, always I can write it as 1 by e raised to infinity, right? 1 by e raised to infinity means e raised to infinity is a big value, infinite value. So it goes to 1 by infinity, that tends to 0. Okay, so this value is actually e raised to minus infinity is actually 0. Okay, 0 minus, what is the second limit? It is 0, so e raised to 0 is 1. So what you will get is minus 1 by 4. Actually we have reversed the limits, right? Actually the limit as the t advances is from minus infinity to 0, but I have reversed the limits here, 0 to minus infinity. So the answer will actually be the negative, right? Okay, so I can write it as, therefore integral minus infinity to 0 e raised to 4t dt is equal to plus 1 by 4, and that is the energy. Okay, so we got energy as a finite value and its value is 1 by 4, right? So now we got energy as finite. Now let us find out power. Okay, power is equal to, you know the equation, limit t tends to infinity. It is a non-periodic signal, so 1 by t integral over one time period 0 to t and e raised to 4t dt, right? E raised to 4t dt because it is x square of t dt. Okay, right, then that becomes limit t tends to infinity 1 by t into e raised to 4t by 4 within the limits 0 to t. Okay, I think we don't need to go further into this expression, because while we evaluate this integral by putting the limits, it will be e raised to 4 capital T minus 1 by 4. Okay, we cannot take capital T outside or something, so what you will encounter is limit t tends to infinity 1 by t. What is limit t tends to infinity 1 by t? It is 0, right? Okay, so this expression will end up in the value 0. Okay, so consolidating, we have got energy as a finite value 1 by 4 and power as 0. Okay, so definitely this signal is an energy signal. Okay, so there is a second question for this, e raised to minus 3 mod t. Okay, first let us have an intuition about what or how this signal looks like, and whether it is power or energy signal. So e raised to minus 3 mod t will be a signal like this. Okay, it will be decaying in the positive time axis and also decaying in the negative time axis. Okay, this is e raised to minus 3 mod t. So this signal is clearly although an infinite duration signal, but the signal's amplitude is converging, right? In the positive direction it is converging, in the negative direction also it is converging. So such signals which are converging in nature are always energy signal. Okay, so this is an intuition about this signal. This is an energy signal, this could be an energy signal, and let us do it mathematically. Okay, so before moving into mathematical steps, let me ask you, what is mod t? How can you mathematically represent mod t? Mod t is equal to plus t for all time positive time, t greater than 0. Okay, and mod t is equal to minus t for time negative, t negative. Okay, this is mod t, right? Then only this t always becomes positive. Okay, similarly, what is e raised to minus 3 mod t? Let me write e raised to minus 3 mod t. Okay, you know the expression for mod t, right? Similarly, you have to write e raised to minus 3 mod t. So I can write e raised to minus 3 mod t equal to e raised to minus 3t for t positive, and e raised to minus t, that is, e raised to minus 3t, that is e raised to plus 3t for t less than 0. So this is e raised to minus 3 mod t. Okay, so with this information in hand, we can easily proceed to finding the energy of the signal. Energy is equal to, as usual, minus infinity to plus infinity mod x of t square. This signal is a real signal, so I can write it as x square of t dt. So that is equal to, now listen, in this integration there are two values, two parts, right? From minus infinity to 0 there is one expression. I can write it as e raised to 3t, right? Because e raised to 3t is for t negative, so t negative e raised to 3t. This graph is e raised to 3t. Similarly, here I can write it as e raised to minus 3t, because the reason is For positive t, the function is e raised to minus 3t. Okay, so for positive t, the function is e raised to minus 3t. Alright, so I can split this integral into two. That is one in the negative time axis from minus infinity to 0. Okay, so what is the function at minus infinity to 0? That means negative time, it is e raised to 3t. Okay, so e raised to 3t the whole square, right, dt, plus the second half of the integral is in the positive t axis, that is from 0 to plus infinity. Okay, and what is the function at positive t axis? It is e raised to minus 3t. Okay, so e raised to minus 3t the whole square dt. Now this is only a matter of finding the integral. So it is minus infinity to 0 e raised to 6t dt plus integral 0 to infinity e raised to minus 6t dt. That is equal to, first integral is actually e raised to 6t by 6 from minus infinity to 0, okay, plus minus 1 by 6 into e raised to minus 6t from 0 to infinity. Okay, now let us substitute the limits. First limit is 0, so e raised to 0 is 1, minus second limit is e raised to 6 into minus infinity, right? E raised to minus 6 infinity is 0. We have already seen that. Okay, plus or minus 1 by 6 into, again, e raised to minus 6 into infinity means it is e raised to minus infinity, that comes to be 0, minus e raised to 0 is 1. Okay, so this values become on simplification, it is 1 by 6 plus 1 by 6. Okay, that is equal to 1 by 3. Okay, so we started with energy of the signal and ended up it as 1 by 3, which is a finite value. Okay, so we got energy as a finite value. Now what is power? Power, this signal is again a non-periodic signal, so its power equation is limit t tend to infinity 1 by t integral over 1 period x square of t dt, right? X square of t dt means e raised to minus 3 mod t square dt. Again, what we have to do is, again, limit t tends to infinity 1 by t into, split this integral into two halves. It is minus infinity to or rather I can use this equation because this is a two-sided signal. This is integral minus t by 2 to plus t by 2. Okay, so integral minus t by 2 to plus t by 2, again e raised to minus 3 mod t the square dt. Actually, again we have to split this integral into two, from minus t by 2 to 0, then 0 to t by 2, but you don't have to do this because again this will come as we have encoded in the previous problem. Here in this bracket there will be some term with e raised to minus 3 capital T. We cannot take t outside the bracket, so it will not cancel with this t. So what you will encounter is limit t tends to infinity 1 by t, and that comes to be 0. Okay, so this integral will end up in 0 because of this factor, limit t tends to infinity 1 by t, and we cannot take any t outside. This is not possible. Okay, so power is 0. So what are we facing? We are facing the situation that energy is finite, power is 0. Therefore, the signal e raised to minus 3 mod t is energy signal. Energy signal with energy equal to 1 by 3. Okay, that's the final answer.